First, let's see some code that counts the words in a string using a dictionary. So up here we have a very long line 1 that I've wrapped around a few different times because it's so long. It's just meant to be a long string containing lots of words to make our word count feature a little bit more interesting. Lines 2 through 6 are just going to do some maintenance on this string. They're going to remove the periods, remove the commas, remove the apostrophes, and make everything lowercase. The reason for this is that we don't want our word count feature to count words with a period as a different word from just words by itself as a different word from words with a comma. We also don't want it to count a capitalized it as a different word from a lowercase it. So these 4 functions basically just clean the string so it's easier to count the words. Notice that in each case we have to set my string equal to the results of that method call. These methods don't change my string directly because my string is immutable. We have to manually assign it to the result of those method calls. Then on line 7, we split the cleaned string into individual words separated by spaces. So now we have a list of every word in my string. Each item in the list is a single word. On line 9, we create an empty dictionary because we haven't counted any words yet. And then on line 10, we start a loop over every word in that list. For each word, if the word has already been added to the dictionary, then we increment the number of times it's been found by 1. Word dictionary with the key word gets the value of the number of times that's been found so far. And if we're finding it again, we add 1 to it. If the word wasn't in the dictionary though, then we create it by setting that key equal to 1, because the first time we find it, it'll always be the first time it appeared in the list. And then at the end, we print the dictionary to see what the results were. So to trace through that a little bit, the first word in the list would be this, now lowercase. List was not found in word dictionary, and so we would call word dictionary with the key this, and set it equal to 1. So now our dictionary would contain one item, the word this, and its value would be 1, because it's been found 1 time. That would repeat for is, the, string, whose, words, we, would, like, to, and count. And it isn't until we get to the second this that we encounter a repeated word. So when we encounter that, then the first branch of our conditional will trigger for the first time because the word this is already in our word dictionary. So instead, it's just going to grab the value of that and set it equal to itself plus 1. So now we've found 2 instances of the word this. That would continue for every word in that string, and then at the end, we would print out the counts for all those different words. And we could visually check this if we wanted to. For our second example, let's define the seating chart for a wedding. First, we'll show how we could use this to locate a particular person's seat, and then we'll show how we would use this to generate a list of all the people at each table. For this example, we'll keep it simple and assume we're only assigning people to tables, not to specific seats at the tables. And let's assume 3 tables, 6 seats each. It's a small wedding. First, on a very long line 1, we would create the seating chart. Each key is a name, and each value is a table number. So David is at table 3, Lucy is at table 3, Dana is at table 2, and so on. Notice that we couldn't reverse the order of these keys and values right now because we would end up with more than one key of 3 and more than one key of 2 and so on. But what we could do is use numbers as the keys and a list of people as the value. So the key 1 could instead have a list of all the people sitting at table 1. But for now, we'll stick to this way of defining each person as the key and their table as their value. Line 3 will run a loop over every key value pair in the dictionary. Our keys represent names and our values represent table numbers, so I'm calling these name, comma, table. Those are just my variable names. The key from the dictionary will still become the name, and the value will become the table. For each of those, we print the name, followed by the string is seated at table number, and then the table number. And we'll tell print not to use a separator by default so that our pound sign will appear right next to our number. The result of this list is this first half of the output over here, and I'm actually truncating it because there's a lot of different people in this list. But what we see is that for every person in our seating chart, this code prints the name, followed by the string is at table number, and then the value from that dictionary. Sophia was at table 2, Lucy was at table 3, Tara was at table 2, and so on. So here, we iterate over every key value pair in the dictionary, assigning the key to the variable named name, and the value to the variable named table, and then printing that each name is at the corresponding table. The second half of this code flips this on its head. It instead is going to build a list of all the people at a particular table and print them all together. It does this by iterating over all the tables. We know there are 3 tables, so we define a range from 1 to 3, which means putting 4 as the latter number in our range. The first time the body of this loop runs, I has the value 1, and so it prints the guests at table number 1, because I is currently 1, are, and then it just stops. It doesn't print anything else yet. And that's because it's going to again iterate over every key value pair in the dictionary or in the seating chart, and again assign each key value pair to the variable names name and table. But what it's going to do this time is check to see if the table for the current person in the dictionary matches the table that we're looking at. If so, it goes ahead and prints that person. And then after running that loop for a particular table, it prints to jump down to the next line. We're specifying to end each print statement inside the loop with a spacebar, which provides our spaces between our different people as they're printed. So that's a much more complicated example of the way we might use a dictionary. And we could also accomplish this second goal differently. Instead of just printing them directly, we could instead create an inverted dictionary where we use the table numbers as the keys and have a list of people as each table number's value.